Good morning, good afternoon. Welcome to a Portworx demo using role-based access control and Amazon Web Services EKS, Elastic Kubernetes Service. I've already deployed EKS here with 3 nodes. I've also already deployed the storage cluster for Portworx. So let's do some digging into how exactly we deployed it by looking at the storage cluster YAML. So it's a pretty standard deployment. The one difference is we have security section here. And when I deployed it, the only thing I added was the enabled control equal true. And then some defaults were added along in the auth section. So we are just going to use a self-signed configuration today, but if you have an OIDC or with JWT, JSON Web Tokens, you would configure this specifically for your environment. We do not have that here today, so we're just going to go with the defaults. When this was enabled, there was a couple different values that were created, tokens for us created. And let's take a look at what secrets got created. You'll see the PX shared secret. So this is how we'll self-sign things. But then there was also an admin token and a user token created at that time. So let's kind of take a look at this user token that was created automatically for us here. So if we run secret on this and output it as a YAML, it's going to be base64 encoded. So we're going to take this and decode it with base64. And this is what we get. This is a JSON web token. So if we switch over to a web browser here and go to jwt.io, we will be able to decode this token and take a look at it. So this is the decoded information. So here's the payload. And one of the things in this payload is, so this is defaults here. So a PX user token at operator.portworx.io. As you saw from the self-signed, this is our issuer right here. And then we have the roles. So in Portworx, we have 3 defined roles by default: system.admin, system.user, and system.view. There are user created roles that can be done. It's all API based, so you can set a role that can only do certain things based off of API calls. Portworx documentation goes through all this. And what's important here is the subject, sub. This is this is a unique identifier for this user. So let's switch back to our terminal here and let us actually build some namespaces. So first thing we're going to do is we're going to create 3 different namespaces. Again, kind of very much along the lines of how we had the system.user, system.view, and then the guest user. So we'll create namespaces for each of those. The next thing we need to do is we need to create a storage class that's going to be used for that. So I already have this px.tenant storage class here defined and ready to be created. So you'll notice in the secret namespace here for each of the different provisioner, node publish, and controller expand, it's using a variable pvc.namespace. So when a PVC is created in that namespace, it'll look for the px-user-token. You could just have this use the default that's in kube system, but we want to show multi-tenancy here and how that all works. So let me go ahead and create this storage class. And then next thing we're going to do is we're going to create tokens for each of our users. So we are going to use a utility called Pixie C. So Portworx client. It's a Kubernetes control kubectl plugin that you can download. It's free and is available as is. So there is no support for it at this time. But the first thing we need to do is we need to decode that shared secret, because that's how we're going to assign these user tokens. So first thing I'm going to do is create a system user token. And again, like I mentioned, I use the Pixie client there to be able to create the token, generate the token. And now I'm going to create a secret in the system-user namespace called px-user-token from that system user token. And then the next thing I'm going to do is create one for system view. And again, create the secret there. So I am not creating a token for the guest user namespace. I want to showcase what happens if you try to create a persistent volume claim without having the token there. So next thing we're going to do is we're going to have a persistent volume claim that we're going to use. So I already have a example PVC here. So what I'm going to do is just create this across in each of the different namespaces. So system view, user, and then in the guest. User namespace. So we can do kubectl get pvc-a to see all the different PVCs that were created. And you'll notice that only a system user namespace PVC has actually been created. So if we look at these, we can use kubectl describe in the system user namespace. Got the PVC. So we'll see it was created successfully for that user, right? Well, let's look at the view and why that wasn't able to be created. So we'll see here, failed to provision volume in the storage class because this user only has system.view capabilities. And then if we look at the guest, we're going to have a slightly different error. And this is failed to provision because no token is generated here. So without a token, no PVCs can be created. So that's some information about how role-based access control and multi-tenancy can be used together. Well, we need to go further than that. We need to be able to audit all this information so that we can check to make sure that our security best practices and requirements are being followed. So that brings in auditing. So Portworx provides two logs that are available, the access log and an audit log. AWS EKS provides CloudWatch Container Insights. So I've already deployed Container Insights here, but let's look at some of the configuration information that went into enabling CloudWatch to monitor these logs. So let me scroll up here. The first thing I had to do is I generated a specific Portworx-log conf for FluentBit, which is what Container Insights uses. So again, I'm just tailing these two logs and then writing them into a new log group called Portworx. So you'll see AWS/Container Insights/ my cluster name / Portworx. So that's the first part. Second part is I needed to add a new parser called log format. So it's a very basic logging format, comma separated. And then finally, I had to actually go into fluent-bit.conf and then tell it to include their Portworx log-conf in their configuration. By default, though, FluentBit does not monitor the var lib, so I also had to edit the daemon set and add in the var lib volumes to the volume section and the volume mount points. So that allows FluentBit to now be able to monitor the logs. So let's switch back over to our web browser and look at CloudWatch. And here by default, there's going to be 4 log groups already created for us: application, data plane, host, and performance. The Portworx log group was created when we created the Portworx-log configuration in FluentBit. So let's look into the Portworx configuration here. So you'll see we'll have 6 logs, 2 for each node. And what's nice is we can come over here and search all log streams. So here we're going to just look for create, because we want to see where those failures occurred and where they succeeded. So you'll see we have 2 success messages here for a system-user, where it was successfully able to create that volume. And then you'll see we have failures, access denied, for the system-view user. So again, this is just a log format separated so we can easily look at the information about it. So the method it was trying to do was volume.create, and its role was system.view. And we already saw that that role does not have the capabilities to actually create volumes. It can only view volumes. But if we look down into the authorized version, we'll see system.user, the same method, create, and then the success here of where it was created and information about the volume that was created. This is the volume ID in Portworx. So that is how role-based access control and auditing will allow you to build a secure system around your existing security and compliance rules. Thank you.